Good evening, everybody. Thanks for coming to this presentation. My name is Alvaro Sanchez. I'm coming from Madrid, from Spain. I'm a Java developer myself. Used to work for BA Systems and Sun Microsystems. Rest in peace, all of them. I created my own company a few years ago, but since 2015, I work for Object Computing, OCI, which is the company behind Groovy, Grails, and Micronaut, which is what we're talking about. You have my Twitter handle down there if you want to reach out to me. So this tools in action session is about Micronaut, but more in particular about serverless functions. What are the features about serverless that we offer in the framework for you? But before getting there, I would like you to understand what Micronaut is. So how many of you is aware of Micronaut and what it is for? Raise your hands. Less than a quarter. So I have a small video for you.
Increased demand for speed, developer productivity, simplicity, and robust cloud services integration leads to an increased demand for Rust services and JVM-based microservices that respond quickly and don't rely on heavy runtime memory requirements. That's why the team that brought you Grails now introduces Micronaut, a polyglot framework for the rocket speed of today's developers. It's easy to implement, features quick instant startup, blazing fast throughput, requires a minimal memory footprint, and is simple to test and run. Micronaut is natively cloud native, open source, and always free. Ready to blast off?
Micronaut.io if you want more information. Well, the video is just a marketing video, but I think it's useful for the purpose of explaining what Micronaut is. So as I told you, I work for OCI. OCI is now the company behind Groovy, behind Grails. And you know, Grails is a web framework. It's 10 years old. And in this 10 years journey, we've learned quite a few lessons about developer productivity, how to make things easiest for developers, and what a framework should be in 2019 or even 2020 or whatever. So Grails is based on Spring. So essentially, Grails application is a Spring Boot application. But we found different challenges, to say, with the either Spring or Grails offering. And it's essentially the amount of things that happen at runtime. So if you now Spring Boot, it's an amazing technical achievement, but it does many things, certainly like dependency injection and you have security, cloud services, many things, but most of the things happens at runtime. It uses the reflection API to read your code. Every single member of every single class of your application will be read. Because reflection is expensive, they build reflective metadata, which is cached, and that takes memory. So it's certainly not fast for large applications, right? So we came to the conclusion that it's probably better to start afresh and to build something from scratch today, and with the cloud in mind. So that's why we call Micronaut natively cloud native, because it's built from the ground up with microservices in mind. And despite all of that, we wanted to offer the same productivity as the people already have with Spring or Grails. So that's the two ideas I want you to get. Is the productivity for a developer, but the performance, because the difference with Micronaut is that we do everything with ahead of time compilation or compile time, right? So Micronaut at its core is a dependency injection framework. And on top of that, we have built many things around that. And everything is done compile time using annotation processors for Java and Kotlin, and AST transformations for Groovy. Those are the 3 languages we support. It's really lightweight, it's reactive based on the reactive streams API. So you can use RxJava, or you can use Project Reactor in your applications. And it's got many features like for cloud development and so on and so forth. Just a hello world for you to get an idea of how it looks like. We have a hello API interface. We have a controller. So one of the things we've tried to do is to embrace the programming model which is already existing in Spring and Grails. So the existing concepts like controller actions and things like that, they remain at Micronaut. We didn't want to reinvent all the names because we wanted people coming from Spring or Grails to feel like at home. That said, this controller could be written in a similar way in Spring Boot, right? So there's nothing special here. One of the interesting things here is, for instance, this client for this controller. So this is actually runnable code. So this could be on a file together with a build file for the dependencies, and it'll work. The client annotation you hear will generate an HTTP client at compile time. This could be compared to Spring Cloud Feign, if you know that. The difference is that we generate the client at compile time. We do dependency injection at compile time. We have an AOP framework, which is implemented at compile time. So we try to keep to the minimum the cases where we use reflection. Actually, I don't think we use reflection at all. In order to test this, the approach is similar as with other frameworks like Vertex or Ratpack. There is an embedded server instance that you can spin up instances of your application in your code, and that will allow you to use dependency injection in your test. So the idea is that you spin up an instance of your application, and from there you can choose from whether, for instance, retrieving an HTTP client attached to that instance and make HTTP request to your application, or to do dependency injection on your test to retrieve a bin and make a call to that bin. So what I'm doing here, for instance, is to retrieve the client that I defined in the previous slide. I'm retrieving it from the application context using the add-inject annotation. This is actually the Micronaut test annotation is a JUnit 5 or Spock extension to do that. You can use plain JUnit 4 if you like. So the only thing you need to be aware of is that you need to run the embedded server by yourself with a Vue4 class. But running the embedded server is one line. Getting the bin from the application context is another line. So it's really easy to test this in isolation. It's a real functional test. So we're running a real instance of the application. You can communicate with it with HTTP. And it runs really fast. On a test environment, is about milliseconds. So Micronaut is based on Netty. So it's not based on the Serverless API. And therefore, like many other frameworks based on Netty, is really fast to start up. So we can say a newly created application could take less than a second to start. It can be run on as low as 7 megabytes of heap space, which is really small. Because and that's like a hello world, right? But if you create like a larger application, we can we can be talking about, I don't know, 2 to 3 seconds to start, and dozens of megabytes of heap, depending on what you're doing. But the footprint, so where you start is really low, sorry. It's natively cloud native in a way that since inception, we've built specific support to make your lives easier when using cloud features, like for instance, service discovery. We support Consul, Eureka, Route 53, and Kubernetes. We do both the registration side of the service discovery and the service discovery client. You can use a distributed configuration with Consul and AWS parameter store. You can have HTTP clients like we saw before. The clients are load balanced by default, and you can use a Netflix ribbon if you put it in the class path, or well, basically that. In terms of tracing, we support Zipkin or Jagger, and we also offer support for serverless computing with AWS Lambda, and Azure is on the roadmap. So how do you get started with Micronaut? The first line you see there is to essentially install SDK-man. If you don't know SDK-man, you should. SDK-man is a tool to install SDKs, if you like. So you can install Java, Maven, Gradle, Spring. There's like a dozen of candidates, tools that you can install through SDK-man. It'll take care of the environment variables, the symlinks, so it'll do all the heavy lifting for you. It's really convenient. Once you have SDK-man installed, you can install the Micronaut CLI. The Micronaut CLI is a utility we offer for developers to get started with projects. So its purpose is to generate a skeleton of a project so you can get started. But a Micronaut project is essentially build file with dependencies. So you can use Maven or Gradle, Java, Groovy, or Kotlin. For testing, you can use the unit, Spock, or Spec if you're doing Kotlin things. And the support for what Spring calls starters. We call them configurations, and there's few of them for things like, for instance, RabbitMQ or Kafka or MongoDB, Hibernate JPA. So there's like 20 or 30 different starters or configurations for you to easily integrate a particular technology. In terms of serverless or functions themselves, the root of the support are the functional interfaces. So we have an annotation called function bin, and that will eventually become a bin into the application context. And the actual implementation in this case is Java util function. So it's pretty standard stuff. So this function in particular, which validates ISBN, takes a request object as inputs and returns a response object as result, right? So that's the apply method, and then you do here your things. So from here you can do many things that the framework already offers you. So you can, for instance, inject an HTTP client and make a request to someone else, or you can do dependency injection on different services of your application, your code, or whatever. So there's no limit potentially on the things you can do. So to implement your function in Java 8 or in Java, to say, you use Java 8's functional interfaces depending on what your function is doing. Those are the ones supported. Or you can alternatively, instead of having a function bin, you can have a factory class, which can produce multiple function bins, like in this case, right? I'm returning a lambda here, so, or a method reference, sorry. So that's another option. In terms of Groovy, the Groovy functions are as easy as a script. There's nothing else you need. This is well, you obviously need the rest of the build, right? Or essentially the build of Gradle with the dependencies. But other than that, there's nothing else in this code to be running. And, it's a statically compiled Groovy script. It's got dependency injection as well, so we've got you covered. How do you test functions? There's different ways to do this. So one is obviously you could create a unit test. So if you do a unit test, you will mock your collaborators and probably instantiate your function bin, call the apply method or get or whatever functional interface you're using, and then make assertions on the result. The interesting part is, how do you test this as a functional test, as a end-to-end test, right? So I normally don't want to test this mocking a lot of things because I may miss some use cases. So the first approach would be to test them as a REST endpoints. That's something that Micronaut takes care of you. So for each of the function bins on your application, Micronaut will expose them as a REST endpoints. So you can grab any HTTP client, or actually a function client, which is a specialized version of the add client we saw before, and then make requests to your function, right? This function client is aware of the environment where it's running. And if it's running on a test environment, it'll know, that it needs to invoke the REST endpoint exposed by Micronaut. But if you were going to run this as a function itself, you could have a different function calling the other function, right? And this second function could have a function client to the first one. So the function client will be aware that it's running in AWS and will look up the original function in AWS to make the invocation. There are many things in the framework which I don't have time to explain. But for instance, one of the cool things is like the secret breaker pattern we have. So we support historics actually if you want to use it. And in this case, for instance, this is a really useful use case because when you deploy your functions to AWS and using the Java 8 runtime, likely the first request will time out because they didn't they don't get a chance to respond within 30 seconds. But once it's warm up, you can make all the requests you want. So we use the @retryable annotation to essentially retry, right? So we want to be fault tolerant. And again, all the logic behind this implementation of the @retryable is generated at compile time for you. This is what I told you before. So the same function client, when it's got properties telling him that it's running on AWS, we actually detect whether the application is running on AWS, based, for instance, on the metadata endpoints. And in this case, it'll be a remote function invocation. Functions can be run as well as CLI applications. In this case, the build is configured in such a way that you can pass the call to your function from the standard input. This is interesting because it allows Micronaut functions to be run and deployed on platforms that read the standard inputs, like for instance OpenFast. That's actually, so those functions, Micronaut functions work on OpenFast as well as AWS. In terms of Graal, you've probably heard about this. Is becoming a popular topic and technology. It's really interesting. It's a polyglot virtual machine from Oracle. Apart from the actual GraalVM and the substrate VM as well, they've got a utility. So Graal is able to turn Java code into a native image, and that allows you to have, like, for instance, a Micronaut application that runs in 20 milliseconds or 50 milliseconds. It's really fast because it's a native image. We're actually working closely with the GraalVM team at Oracle, because Graal is still not on a stable release, and we're working closely with them to have a working version of Micronaut there, right? There's many things that already work in Graal with Micronaut, so you can have HTTP server clients and functions as well. The problem becomes when you want anything else, like for instance Hibernate or database. Those frameworks are not prepared for running Graal. That's a different subject. So I've got some things to show. Got 8 minutes left. So I got a small function. This is what a typical Micronaut application looks like. We have the typical application class. This is very similar to Spring Boot. This is the function bin. In my case, this function posts messages to Slack, and to do so, it uses a Slack service, and the Slack service uses a Slack client. This client is generated at compile time, as I told you, and we've got annotations here to understand what are the endpoints we need to make the invocations to, where are the parameters, etc. So in this case, Micronaut will receive those parameters, will create a JSON payload for the endpoint, will make the request, and will do its best to convert the response to whatever return type you define here. The URL is configured in the configuration file. So in this case, I'm having a configuration value with the URL as well as the token. And what else? So I'll run this locally. And we should see a message showing here, which is hello. This is coming from the test local function test. One of these guys is this guy here, right? So this is the test of the function, right? In this case, I'm actually testing the HTTP client. In terms of AWS support, there's few things we could do. There is AWS SAM, which is a serverless application model, and it allows you to run your function in a local environment. So there is a command. There is a SAM local invoke, and then the function message, and of course this fails doing the demo. Thank you, the demo gods, for this. Well, this I tried that a few minutes ago. The small things we can do. So we can invoke this from a Java file. Yes, that's probably the case. Actually, I'm doing assemble. Okay, this looks better. This something from Amazon that detects your credentials, if any, and then it'll create the container that will, in a similar way, that will be used by the actual production environment. But these were run locally, and here we have the message. And also as a Java file, the invocation as a Java file is simply like doing an echo and then piping to the java-jar command. And we have here the result. And I've got this deployed into AWS. So I created a Lambda API proxy. So we can make an invocation to the public API proxy, which is this one here. This is probably warming up the Lambda. There we go. In case you don't trust me that I'm actually running the same thing that I have here, I will make a change in Slack service and then let's say Devoxx, and then we do an upload. No, this deploy. This deploys the Lambda to AWS. Come on, I'm running out of time. And then we can make the invocation. The other thing I wanted you to show is the ability to make a request to use Graal as a native image. I've got here a different different function. This function is just a utility function to check whether a VAT is valid in Europe, right? There's a public service from the EC that allows you to check that. So you can make a request to so what you have here, this is a native image generated with Graal, and it's really fast. And if I make a different request, or basically it tells different tell me it's not valid, right? So I generated this image out of this function, right? This is a function. It's not a hello world. It's not any more complicated than that, so it's fairly okay. But it involves having an HTTP client to a different service, JSON serialization, and it's able to compile as a native image. And well, here's the change we did on the invocation. So time's up. Please rate me. Devoxx encourages people to rate talks. So if you like it, give me 5 stars, for instance. That's an idea. If you need suggestions, I'll be around the whole week. So if you want to know more about Micronaut, don't hesitate to reach out to me. There will be a couple of talks on Thursday. One is actually from Graham Rocher, which is the creator of Grails and creator of Micronaut. He will do like the introductory talk. And other than that, I don't know if we've got time for questions. Thank you very much. I've got some swag, which is a glass for the first question for free, if there's any. No, thank you very much.